Today's lesson is a continuation of the previous lesson about significant figures. Today we're going to see how we can use the rules for significant figures and other things to express a calculation to the correct level of precision. And so I strongly recommend that as you watch this video that you follow along with your own calculator and do the problems as I do them on the screen. Now the first thing that we're going to look at will be addition and subtraction problems. And so here's a very simple addition problem. And so when you type this into your calculator, you get an answer. It's 99.09. And that's the calculator answer. Now, when we're adding or subtracting, in order to express the answer to the correct level of precision, we want to count the decimal places in the two numbers that we're adding or subtracting. So for example, in this first number, you can see that we have 3 decimal places. And in the second number, we also have 3 decimal places. And so as a result, we want to be consistent in our answer. And so our answer should also have 3 decimal places. And so instead of expressing this as just 99.09, the correct scientific way to express this number would be as 99.090. So we could add an extra 0 to make that have the correct number of decimal places. Now here's another example. If we add that, or add those numbers on our calculator, we get 211.311. Now once again we have to look at the number of decimal places. Now, the first number has 2 decimal places and the second number has 3 decimal places. And so when we don't have a consistent number of decimal places, the rule is we always go with the least. We always use the number that's the least precise. And so that means that we have to have an answer with 2 decimal places. And so that means that we have to stop after the second decimal place right there, and then we use the next number for rounding purposes only. And so if you ever have a number that's 0 through 4 in that position, we round down. If we have a number that's 5 through 9, we round the adjacent number up. Well, this is a 1, so that means that we round down. And so the correct answer that we should report is 211.31. And so that's the correct way to express that answer to that addition problem. Now here's another one. If we take 328.40 minus 75.3, and of course subtraction, the rule for this works exactly the same way as addition. Your calculator answer is 253.1 when you type that in. Notice that the first number has 2 decimal places. The second number has only 1 decimal place. So as we said earlier, we always go with the least precise number. So that means our answer can only have 1 decimal place. And look at this, it sure enough already does have 1 decimal place. So we don't really have to do anything else to it. It's just 253.1. Now let's try another example. This example might be a little bit more complicated, or complex, I should say. 145.45 plus 54.548. The calculator answer is 199.998. And if we look at the decimal places, the first number has 2 decimal places, and the second number has 3 decimal places. And so according to the rule, how many decimal places should our answer have? Well, I hope you realize that it needs to have 2. We always go with the least precise number. And so that means our answer can only have 2 decimal places. So that means we have to stop after the second decimal place. And that next number, that 8 right there, is used for rounding purposes only. So do we round up or down? Hopefully, you realize that since it's an 8, we round it up, and so that makes this 9, and pretty much all the other 9s next to it go up. And so this rounded to the nearest hundredths place is 200.00. So this one's a little bit tougher just because we have to do some more rounding, but hopefully you have had some experience in that. So that's how addition and subtraction works when we have those numbers and we want to express the answer with the correct level of precision. Well, let's try something a bit different. We're going to do some multiplication now. So we'll take these two numbers and multiply them together. 3.204 times 0.080. And so the calculator answer is 0.25632. Now the rule is a bit different for multiplication and division because instead of counting decimal places, we actually count significant figures. And so this is where we have to remember the rules for counting significant figures from the last lesson. So in the first number here, the first factor, all these non-zero numbers are significant. That's a middle zero, so it is significant too. So we have 4 significant figures. And then in the second number, these leading zeros are not significant. The 8, of course, is. And that ending 0 is significant also, since there's a decimal point. So that number has 2 significant figures. And so once again, the rule is similar. We always go with the least. Our answer can only be as precise as the least precise number when we're multiplying or dividing. So that means our answer can only have 2 significant figures. So in our answer, we know that leading zeros are not significant, so that 0 doesn't really count as significant. The 2 and the 5 are, and so that means we have to stop after that second significant figure. And the next number, which is the 6, is only used for rounding. So the 6 means it has to be bumped up. So the answer is 0.26 that you would record. 0.26. Let's try another example. This time we have a division, and we have 76,000 divided by 8.32. Now the rule there is going to be pretty much the same for division as it is for multiplication. When you type this problem into your calculator, you get a number with a lot of decimal places. It's 9,134.615385, and that's what my calculator gives me. Your calculator may give more decimal places than that, or it may be a little bit less. It just depends on your calculator. But we don't need to report all of those numbers. So let's see how many significant figures we should have. Well, the first number here, we have the 7 and the 6 that are significant. These ending zeros, would they be significant? Well, they would not, because there's no decimal place, or I should say no visible decimal point here. So those ending zeros are actually not significant. So we only have 2 significant figures in that number. All 3 of those are significant, of course. So we have 3. And so our answer can only have 2 significant figures in it. And so we have to round this off to 2 significant figures. And so, of course, the 9 is significant, and so is the 1. So we have to stop after that, and everything else is rounded. So that 3 means that we round it down. So 9,134.615385 rounded to the nearest hundreds place would be 9,100. So that's the answer. Now it's okay to have those 2 zeros at the end as placeholders, because remember, there's no decimal point visible there, so those ending zeros are not significant. That number 9,100 has only 2 significant figures. Let's try another example. Multiplication again. 50.3 times 1.99. So the answer that we get here is 100.097. That's the calculator answer. So once again, here we count the significant figures. The number 5 and 3 are significant. The middle 0 certainly does count. So we have 3 significant figures in that number, and we have 3 significant figures in the second number as well. So we have to be consistent and express our answer with 3 significant figures as well. So we know that the 1 is significant, and all these zeros in the middle are significant also because they're middle zeros. And so we have to stop after the third significant figure. And that next number, which happens to be a 0, is used for rounding purposes only. So we round it down. And so the answer is 100. Now, there's a little problem with that because, as you might realize by looking at it, 100 does not have 3 significant figures. As it's written, it only has 1 because there's no decimal place anymore. And so, or no decimal point anymore, rather. And so it looks like we have ending zeros. Well, to make this number have 3 significant figures, there are a couple things we can do. We can just stick a decimal point at the end, just like that, to show that it does have 3 significant figures. Or something else that you can do alternatively is write this in scientific notation. So something like this has the same value. It has 3 significant figures also. So that's okay to do. Let's try one more example with multiplication. We have 300.0 times 3.000, and the calculator answer, of course, is 900. But we have to count significant figures. So this number, we have a decimal point, so we have all those ending zeros that are significant, and so we have 4 significant figures there. And then we have a 3, and then all these other ending zeros that are significant, so 4 significant figures there. And so our answer should also have 4 significant figures. Now, 900, as it's written, has only how many significant figures? It looks to me like there's only 1. There's no decimal point, so those ending zeros aren't significant. So how do we make that number have 4 significant figures? Well, the easiest thing to do would be just to put a decimal point and a 0 after it. So now we have ending zeros and a decimal point, so they're all significant. So 900.0. Let's try a more advanced example before we end the lesson. Let's try a case where we're going to have both addition and multiplication. Now, perhaps in your math classes you have learned that there's something called order of operations. So we don't just solve the problem from left to right. We have to solve the multiplication before the addition. So it's almost like we have an understood parentheses around this part of the problem. We have to do these two parts separately according to the rules of significant figures. So the first part of it, 9.6 times 3.45, we just type that into our calculator, and the answer that you get is about 33.12. And so, since that's a since we have a multiplication problem here, fix that. Here we go. So we have a multiplication problem here. We have to count significant figures. So we have 2 significant figures in that number, 9.6, and then 3.45 has 3 significant figures. So our answer can only have 2. We always go with the least. So that 3 is significant, and so is the second 3. So we stop there. And the 1 is just used for rounding and means we round down. So this part of the answer is going to be just 33. Well, now we can pull down the rest of the problem and do the addition as a separate problem. So your calculator answer for 1.45 plus 33 would be 34.45. And since we're adding, this time we have to count decimal places. And so in this first number, the 4 and the 5, we have 2 decimal places. And in the 33, we have 0 decimal places. And so that means that our answer, we always go with the least, can have only 0 decimal places. So we stop after the 34, and that 4 is used for rounding, and 4 means it gets rounded down. So we actually have to express an answer of 34. Now notice that if you just type this into your calculator from left to right and let your calculator do the work, you would get the wrong answer. So make sure that you do the process here and use order of operations, multiplication first, and then addition. So hopefully after seeing this lesson and working through the examples, you're able to take almost any math problem that you could encounter in chemistry and express the answer with the correct number of decimal places or the correct number of significant figures.